Hello, everybody. My name is Simran Kaur, and today I will be discussing the principle of inclusion and exclusion. Starting off with the theorem, which says if n is the number of objects in a set A, then the number of objects in A having none of the properties A1, A2, and so on is given by the formula right here on the screen. Um, Moving on to the example, we have today how many solutions are there to this equation, while we also have some constraint on the xi's. You might recall we have done a similar question back in week 3. The only difference was that we did not have any constraints for xi's. So for a little recap, for any question of similar form without constraints, we do the following. Let the equation be x1 plus x2 plus goes on to xn equals to k, while xi is greater than equal to 0. And so the number of solutions are k plus n minus 1, cn minus 1. This is a general equation, and our xi's are non-negative integers. So within simple combinatorics, we found the formula for the solutions. Now back to our solution for the example today. First of all, we have the equation and the constraint given to us in the question. Then we know from week 3, we know that for no constraints, n equals to 20C3, where n is the number of solutions. This is for our example today. So our k is 17 and our n is 4. And so we get k plus n minus 1, cn minus 1 equals to 20C3. Now, using the principle of inclusion and exclusion for this example, first of all, we define the properties. So let A1 be the case when x1 is greater than equal to 7, and so on for all the variables in our equation. So now we have 4 properties for 4 variables. And now we need to find n of A1 complement, A2 complement, and so on, as all of our properties need to be false for the solution to be valid, as we have a constraint that is the opposite of our property. So this equals to this formula, which comes from the principle. And here n is 20C3, so this is the number of solutions when there's no constraints at all. Then we have all the other components of this formula actually use substitution. So for summation of n of ai, this is when only one of the variables has its property to be true. So we use substitution. So case one of the properties is true. Solution. Let's say x1's property is true. So then we have x1 equals to y1 plus 7. So now we replace it and we get the equation to be y1 plus x2 plus x3 plus x4 equals to 17 minus 7, which is equal to 10. Now, as we substituted and removed the constraint, we treat it as a normal no constraint question, and hence we use the same formula and get n1 equals to 13C3. Here our k is 10 and our n is 4. Now, as we also have 4 choices for the choice of xi as to which xi will have its property to be true, so we multiply the total number of solutions and we get 4 into 13C3. And so summation of n of ai is 4 into 13C3 as seen here in the formula. And for the next component, summation of n of aiaj, this is when 2 of the properties are true. And it's similar to case 1. In case 2, 2 of the properties are true. Let's say x1 and x2's property is true. So then we have x1 equals to y1 plus 7 and x2 equals to y2 plus 7. And now we replace both in our equation and we get y1 plus y2 plus x3 plus x4 equals to 17 minus 7 minus 7, which is 3. Now again, similar to case 1, we treat it as a question with no constraints, and hence we get n2 equals to 63. Here our k is 3 and our n is 4. Similar to case 1 again, we also have choices. So now we have to choose 2 out of 4 variables. So we have 4 C2 choices. And so the total solutions are 4 C2 into 6 C3, as seen here in the equation. And for the cases after that, in this particular example, for the cases where 3 of them or even 4 of them have their properties true, that is not valid, as even if 3 of them are for example, if x1, x2, and x3 are equal to 7 each, that will sum to 21, and our total sum is no more than 17. In fact, it's exactly 17. So that case is not valid, and similarly, the case where we have 4 properties. True is also not valid. So for both these cases, the number of solutions is 0. And that is how we piece by piece get all of the cases, and then we calculate the answer, and that's how we have a number of solutions. Thank you so much.